Water is the oil of the 21st century, and no one likes to think about it, but we've seen the 20th century and we've seen wars fought over oil. We've seen a lot of things happen like that. In the 21st century, I'm afraid we're going to see similar things happening about water. We had a civilization for thousands of years without oil, but we've never had it without water. We always have several projects going on in the lab, and probably the project of primary importance right now is a chemical analysis kit that we've developed. It's similar to a kit you would use to measure chlorine in your swimming pool water, except this kit is actually designed to measure some chemicals that are a little bit more complicated to measure. This kit will be useful for a lot of water utilities across the United States that can't afford to have the analytical laboratories and the high-end instrumentation to do that type of analysis. We expect it to sell for about $9,000 on the open market. That's what we're trying to do, is to take that product from the research laboratory to the water utility and to take it onto the market. We've been trying now, actually since about 2002, through a grant from the American Water Works Association Research Foundation, to develop, I'd say, simpler and less expensive ways to measure water quality, particularly with a particular focus on drinking water chemistry. We started out to develop these analytical methods that could be used for online and real-time monitoring. So we take human error out of the picture. Analytical instruments don't get tired, and humans do. And if we have these analytical instruments set up running automatically, they can give us, the water utility and also the customer, information about the water quality in real time. And so the idea would be ultimately that there would be a website that the customer could log on and could actually understand what the water quality is in real time, right now, without having to wait 3 to 6 weeks for results to come back from a laboratory. You can think of a NASA water system as similar to a water utility, except a lot smaller. And so NASA is interested in looking at the water quality in real time, and they can use the component that we're building as the eyes and ears of that water system, so that our system, our device, will tell them how good or how bad the water quality is, and then send a feedback mechanism to tell that water system to operate in a certain manner so that the water quality is improved for the astronauts and the mission specialists.